All right, we're going to review right now how to decompose this expression into partial fractions. The very first thing that I want us to do, I want us to factor. All right, we need to be able to factor this trinomial. These are very, very easy to factor. All right, I'm looking for two numbers that multiply together to equal a negative 20, and two numbers that add together. Even though you can't see it, just know that there's a 1 there that add together to equal a 1. Now, always start, everybody, always start with your factors, because the factors will give you your answer, essentially. All right, the factors of 20 are 1 and 20, 2 and 10, and 4 and 5. Those are the factors of 20. Now, only one set, put times here between them, only one set of these numbers can get you to a possible 1. And it would be the 4 and the 5. Because if I have a positive 5 and I have a negative 4, that's going to give me a 1. And what's 5 times a negative 4? A negative 20. So your factors are 5 and negative 4. 5, negative 4. So what you're going to do, once you find those factors, you're going to plug them in. I've got an x plus 5. And I have an x minus 4. That's the factors of x squared plus x minus 20. All right, whenever you're trying to solve for the partial fractions, you're going to take your original expression with the factor trinomial right here, and you're going to set it equal to a over one of the factors, which is x plus 5, plus b over the other factor, which is x minus 4. So right now, this is what you need to have on your paper, all right? After you have that down, you're going to take everything right here. You can take everything, this whole equation. You're going to multiply every single thing by an x plus a 5 and an x minus a 4. So we're going to take this and we're going to distribute it to every single number. Now, I'm not going to write everything out. I want you guys to look carefully. If you multiply all of this times this, what's already in the denominator? An x plus 5 and an x minus 4. So what's going to cancel out? This x plus 5 will cancel that x plus 5. This x minus 4 will cancel this x minus 4. So what's the only thing you have left in the numerator? You just have 5x plus 7. Okay. All right. Now over here, if we take this right here, I'm going to highlight it. If I take this right here, and I multiply it to the a, what's eventually going to cancel out? The x plus 5s will cancel out. So here's what we have left. We have an a, and in the numerator we have an x minus 4 that still is left, because this x plus 5 will cancel out this x plus 5. And we have x minus 4. If we take all of this and multiply it to b, what's going to cancel out? The x minus 4s. And we're left with an x plus 5. Okay? So everybody should have this right here. This right here is the hardest part to get to. At this point, it's relatively easy to solve from here on in. Okay? So right now, what I want us to do is we are going to either solve for A or we're going to solve for B. To solve for A, okay? And to solve for B, we're going to have to plug in two numbers. So I'm going to change colors right here. Right here, if I wanted to solve for B, I would need to plug in a 4 right here for all of my x's. If I want to solve for B, I'm going to have to plug in a negative 5. So what I'm going to do right now is I'm going to write in the columns here, I'm going to say solve for A. And then over here, I'm going to write solve for B. We're going to do it separately. If I want to solve for A, everybody, if I want to solve for A, I'm going to have to plug in a negative 5 for x. So right here, I'm going to write plug in negative 5 for x. So if I want to solve for A, I got to plug in a negative 5, and that's what I'm about to do. So right here, this whole thing, everywhere you see an x, what are you plugging in? You're plugging in a negative 5. So I'll highlight what I I just did there. Wherever there's an x, I'm going to highlight that in orange. There's an x there. There's an x there. There's an x there. What did I say I needed to do? I needed to plug in a -5 for my x. So I plugged it in right there, and I plugged it in right there. The reason why I did a -5, look what happens when you plug in a -5 right here. What happens to all of my b's? That's a -4 right there. What happens right here if I plug in a -5? What's -5 plus 5? 0. So all of my b's are eliminated. They're gone. And this is all you're going to have left. All right? 5 times -5 is -25. -5 minus 4 is -9. -25 plus 7 is -18. This is where your elementary school teachers are really helpful. All right, if they drilled you on all those adding and subtracting, multiplying, all that stuff. Otherwise, you're just going to be dependent on a calculator, and your life will be miserable. -18 divided by -9 is a 2. We just found what our a value is equal to. Thank you, Mr. Maggi, Mr. Lewis, Miss Savage, Miss Christensen. I think Miss Savage. She was awesome. She was a great teacher. 6th grade teacher. Miss Savage. She was awesome. Mr. Maggi, Mr. Lewis, my 4th grade teacher. Awesome. Mr. Maggi, 5th grade teacher. That's where we all learned how to play chess and chess tournaments. And they all drilled in the importance of you better know how to do multiplication, addition, subtraction, division, all that stuff. So, my a value is equal to 2. Now, what did I plug in? I plugged in a -5 for this. So, what are we going to do to solve for b? What do we have to eliminate?
Probably a -4.
Nope. Close.
4.
4. That's right. So, right here, got to plug in a 4. Okay. Let me erase this real quick.
Can you explain why we have A and B again?
Sure. All right. A and B represent the numbers that are going to be broken down. Our final answer, everybody, eventually our final answer is going to be whatever we get for A and B, and we're going to break this in to partial fractions. This is a fraction. This is a fraction. Together, this fraction plus this fraction will equal our expression. So we're basically taking an expression and we're breaking it down into its parts. Okay? So what did we just found? What did we find for A? We said A is going to equal a 2. So we found A. Now we're going to find our B value. All right. Now let's add a good question. Find why are we plugging in a -5 for x here, and why are we plugging in a 4 for x here? Now right here, I'm going to put a little arrow. The reason why we're plugging in a -5 for x here is we're solving for A. We had to eliminate the other letters. This is the only way to eliminate B. And if you plug in a 4 for x here, that is the only way to eliminate all of my A's. If you look up here, if you plug in a 4 right there, 4 minus 4 is 0, and 0 times A is 0. So all of your A's are gone. All right? So right now we're going to take our expression right here. We're going to say 5, open parentheses, plus 7 equals. Now, I'm not going to write A and 4 minus 4 because I know those are all gone. But I am going to plug in a 4 right there. You're right. I'm going to plug in. I'm going to write B. And what am I going to plug in for x? I'm going to plug in a 4 for x. Because I've eliminated all of my A's, so this is all I have left. So right now I have 20 plus 7, which is 27. Here I have B times a 9, which means I have 9B. You're right. It's going to be 3. Oh. So we have 9B equals 27. You divide both sides by 9, and B equals 3. Now, what I'd like you guys to do right now for your final answer, all right? Now you know what A is, and now you know what B is. Here's your final answer. I'm going to move it right over here so you can see how I set it up. My A was equal to a 2, and that's over x plus 5. Plus, my b was equal to a 3, and that's over x minus 4. These are together what's known as your partial fractions. This is your final answer for number 3. Okay? Because this, the 2 over x plus 5 plus the 3 over x minus 4 together, if you added those together right there, they would equal our original expression of 5x plus 7 over this trinomial. Okay?